So what the heck is a z-score anyway? Even talking to students who understand the empirical rule, there is still a little bit of a lack of understanding of what is a z-score and what's its relationship to standard deviation. So we're going to start with a couple of things here to see if we can explain it in a pretty fundamental way. And I'm going to start with some very, very basic math, which is that division is the same as multiplication. Now, what do I mean by that? That seems like kind of a weird thing to say. I mean, in reality, they're inverse operations, but I'm going to say it's the same. So I'm going to give you an example here. And let's use the fraction 4 divided by 3. So I'm dividing 4 by 3. Well, isn't that the exact same thing as taking the number 4 and multiplying it by the reciprocal of the denominator? So here's my denominator right here is 3. And the reciprocal of that is 1/3. So I can say that it's the same thing as multiplying by the reciprocal of the denominator. And you can see with this problem right here, if I kind of made this 4/1 and I multiplied, multiplying fractions, you multiply straight across and you get 4/3. So, or let's see if we can take a little bit more complicated example. Let's say I had a 3-layer fraction here, and so my numerator is 3x plus 2, and my denominator is this fraction right here, rational function, 3x plus 2 times 4x minus 6 divided by 8. Well, to get rid of the 3 layers, I could multiply my denominator by its reciprocal, 8/3x plus 2 times 4x minus 6, and that crosses out, and that crosses out, and that crosses out, and that crosses out, so that I just have 1 on the bottom. But if I do this on the bottom, I also have to do it on the top. So 8 divided by 3x plus 2 times 4x minus 6. And so I'm just going to take, so I'm multiplying 3x plus 2 times the reciprocal of my denominator. And if I was to do that, so I'd look at 3x plus 2/1, and I can cross out the 3x plus 2, and really I would be left with 8/4x minus 6. But the answer isn't really what I'm that concerned about. What I'm trying to just make sure you understand is that if I'm dividing by something, it's the same thing as multiplying by its reciprocal. So now, still again, without getting exactly into standard deviations right yet, we know that 12 inches is equal to 1 foot. That's a standard measurement. So let's say that I was on a ruler. Here's my ruler, and let's say that over here is 0, and here's 5, and here's 10, and here's -5. And I'm this little tiny person, and I am starting a journey on the ruler. And I am starting my journey at inch 5. These are inches. So that's 0 inches, -5 inches, 5 inches, 10 inches. I'm starting my journey right here at 5 inches. And I am going to go on my journey all the way over to here to 9 inches. So this is where I've gone. I started at 5, and I've ended at 9 inches. So I can calculate how far I went. I go 9 inches, which is where I ended, minus 5 inches, which is where I started. So I can see that I went 4 inches. Well, I would like to know, well, what is that in feet? And instinctively, what we know what we do is we would say, oh, well, we just divide by 12. And that would give us 4 over 12 feet. And that would be 1/3 of a foot. So this 4 inches that I went is 1/3 of a foot. But I want to look at this operation right here. We do this pretty without really thinking about it. But what am I really doing there? Well, I have 4 inches. And I'm really dividing it by 12 inches, I-N-C-H-E-S, inches over 1 foot. I'm dividing it by a fraction right there. And this fraction right here, 12, since 12 inches equals 1 foot, well, this is equal to 1. So what I'm doing right now is I'm dividing 4 inches by 1, and that's 4 inches. But what I've done is I've set it up here. So let's go back to multiplying by the reciprocal. I have a 3-layer fraction. I'm not allowed to have a 3-layer fraction. So I'm going to multiply my denominator by 1 foot over 12 inches. And that means I have to do it to my numerator, 1 foot over 12 inches. So this all canceled out. Now let's just take a look at our 4 inches. I'm going to even rewrite it here. I want to take a look at our 4 inches times 1 foot over 12 inches. And I'm going to make this 4 inches over 1, because we know we can divide anything by 1 and it's the same. So what is happening here is my unit inches is canceling out because it's in the numerator and the denominator. And now when I just multiply straight across, I get 4 feet over 12, and that's where I get my 1/3 of a foot. So again, I take my start point, my end point, minus my start point to get the distance, and then I wanted to convert it to the units that I wanted, which was feet. So I'm multiplying by, essentially I'm multiplying by 1, which is 1 foot over 12 inches. Let's do one more problem using this foot and inches, and then we'll get into standard deviations. But again, I am going to start here at the 5-inch mark. But I am going to go, I'm going to go this way. And I'm going to go, let's say to, yeah, I'm going to go over here to -3 inches. So here's my start. Here is my end. So I want to know how far have I gone? Well, again, I start with my end point, which is at -3 inches, and I subtract my beginning point, which is 5 inches, and I can see that I have gone -8 inches. And if I want to convert that, let's actually write inches so that we can see it a little bit better here. Okay, I've gone -8 inches. And if I wanted that in feet, I would multiply this by 1, because I can multiply anything by 1. But the one that I'm going to use is 1 foot divided by 12 inches. So once again, my inches cancel out, because this is the same thing as like 8 over 1. And what I'm left with is -8 over 12 feet. So that is, come on, divide by 4. That is, I've gone -2/3 of a foot. So I can go negative or positive, but it's the same method. I take my end where I ended and I subtract where I started. I get my answer in the same units. And if I want to change units, I got to multiply by 1. But the 1 that I'm multiplying is the unit that I want divided by the unit that I have. So let's look at a standard deviation problem here. I'm going to use, let's say I have a herd of cows. And my herd of cows, the weight of the cows follows a normal model with a mean of 1152 pounds and a standard deviation of 84 pounds. So these are elbs, pounds. Never could figure out why they could use elbs for that, but whatever. Okay, and just so you know, over here is our formula for standard deviation, and very briefly, without getting into a whole thing about this, the method for finding it is I take for every single cow in the herd, I take that cow's weight and I subtract it from the average weight of all the cows. And then I square it. That's to get rid of the negative signs for those cows that are lighter than the average cow. I add all of those together, and I divide it essentially by the number of cows minus 1. And then I take the square root of that. So you'll notice that in terms of what unit of measurement, the measurement of the weight of each cow is in pounds. And the measurement of the average weight of cows is in pounds. And I've squared it, so I really have pounds squared. But then I take the square root. And so my unit of measurement of standard deviation in this particular example is pounds, right? And so what it's saying is that my average pound, my average cow weighs 1152 pounds, and the average away from the mean, the average weight of all the cows away from that mean is 84 pounds. That's my standard deviation. So I've drawn my normal model here. You know, I've drawn the diagram and I've put in the numbers. And let's say that I have a cow that weighs 1,300 pounds. So that kind of goes right in about here, 1,300. Really, all I need to know is that it's between 1236 and 1320. So how many pounds away from the mean is that cow? Well, that's easy. Here is my start point because I'm starting from the mean. And here is my end point. So I'm going to go end minus start. And the start's always going to be the mean in these cases. So I have 1,300 minus 1152. And that's equal to 148 pounds. So that this is in pounds. And this is in pounds. So 148 pounds. Well, that's fine and dandy. But that doesn't tell me exactly what I want to find out. I would like to know how many standard deviations that cow is either above or below the mean. So I know that, that it's 148 pounds above the mean. But like, how much above average, you know, and that's how we measure, that's a standard deviation, is it's kind of giving us a ruler. So I'm going to take 148, and I'm going to multiply it. Well, let me put in the units here, 148 elbs. And I'm going to multiply that. I want to change the units. I'm going to multiply it by 1 standard deviation over 84 pounds. because my model is telling me one standard deviation is equal to 84 pounds. So one standard deviation over 84 pounds, that's fine. Remember, this is like 148 over 1. I'm crossing out the units, and I have 148 over 84 standard deviations. Oh, 148 divided by 84, 1.76. I am 1.76 standard deviations above the mean. And that makes sense to me because I am between one standard deviation, that was 1152 plus 84, and two standard deviations, that's 1236 plus another 84. So this is 1.76 standard deviations above the mean. These numbers right here on the top just happen to be the integer values of some of the standard deviations. But most of the time, our actual data point is not going to land on one of those integers. So it's really not a good idea to say, well, this cow right here that weighs 1,300 is approximately 2 standard deviations. Yeah, I mean, it's pretty close to the 2 standard deviations. But why I don't care about the about. I'd like to know exactly how many standard deviations it is away from the mean. And that's where I use this formula. So what I'm pointing out here is that a z-score is the number of standard deviations above or below the mean. That's what a standard deviation is. And we're finding it really using the exact same methodology that you would use to change inches into feet, except that in this case, we're not changing inches into feet, we're changing pounds into standard deviations.